Before going into the upcoming tutorial, it's useful to have a general understanding of the edgeEngine architecture. Getting an edgeEngine microservice up and running requires some work. Understanding why you're going to do that work will help you see the big picture. It all has to do with how edgeEngine enables access to the mimik cloud and the mimik networking infrastructure. The most important thing to understand about microservices running under edgeEngine is that they run in a serverless manner. So how does that happen? Well, what's going to happen is you're going to install both the mimik CLI tool and the mimik edgeEngine on your local machine. And mimik edgeEngine has a number of components. The most important component is the API gateway, which is also bound to a single HTTP server that's controlled by edgeEngine runtime. Now, what will happen is when you call a microservice, which you're going to install later on, when you call a microservice's endpoint, the API gateway will create an ephemeral runtime, which will actually invoke the logic of the endpoint and return a response. Then, once that activity is over, once the endpoint does its work, the runtime will go away. It's ephemeral. And this is true for any endpoint that you call through edgeEngine. So in this case, we have microservice 1, endpoint 1. That's going to create a runtime endpoint 1. When we call endpoint 2, it'll create a runtime 2. That'll call endpoint 2. And the same with microservice 2, endpoint 1. Every time an endpoint is called, edgeEngine runtime will create an ephemeral runtime and execute the logic, and then it'll go away. So that's one part that's really important. The other part is understanding the function of the CLI tool. The CLI tool, as you'll learn, will be used to deploy edgeEngine OCI compliant images and make containers based on those images. The other thing that the CLI tool will do is it will allow you to ask mimik cloud to get an access token, and it will pass that access token on to edgeEngine. And the reason you need that access token is to interact with mimik network services and the mimik cloud. So what is it you get when you get access to the mimik network services? Well, the thing you get is access to the edgeEngine service mesh. And the edgeEngine service mesh allows you to interact with the network in three different ways. One way is called a proximity cluster, which will give you access to other edgeEngine devices running in close proximity to you. The other one is networking, the network cluster, which will give you access to edgeEngine devices in a network domain or in your local area network. And the third thing that the service mesh allows you to do is to access services based on the account that the service belongs to. And you're going to see account activity when you do any of the tutorials that are going to be coming up. So what are the features the edgeEngine network provides? It gives you node discovery, it gives you service discovery, it gives you secure tunneling and zero trust security. Also, the edgeEngine service mesh and networking capabilities provide observability and analytics. So there you go. That's what edgeEngine is about. And now you're going to take a tutorial that's going to show you a particular detail about how to work with edgeEngine. The objective of this track is to demonstrate how to build an edgeEngine microservice in a WebAssembly binary and then expose that microservice as an endpoint under the edgeEngine runtime. Whereas edgeEngine microservices are typically programmed in an interpreted language such as JavaScript, WebAssembly modules are programmed in a low-level language such as C++. As a result, WebAssembly modules are very efficient and fast. Thus, they bring a whole new level of power to edgeEngine programming. Under edgeEngine, a developer creates and compiles the WebAssembly binary on a development machine. That binary gets embedded into a tar file as part of the edgeEngine microservice development process. That tar file is the deployment unit that's sent out on the remote device or the desktop device running edgeEngine. There's a small amount of work that needs to be done on the remote device to deploy the tar files as a microservice. If a developer is creating microservices targeted at an iOS or Android device, the respective mimik mobile SDK streamlines the deployment process within the remote device. For desktop computers and small Raspberry Pi machines, the deployment process is done using the Edge CLI tool. In this track, you'll be building an edgeEngine microservice that represents the current time via a RESTful API. The microservices API logic is written in C++. This track shows you how to install the tools and libraries that you'll need to build a WebAssembly module under edgeEngine, install the edgeEngine runtime and edgeEngine CLI tool in the interactive learning environment, download the demonstration code for the WebAssembly module, build an edgeEngine image from the WebAssembly demonstration code, deploy the edgeEngine image into an edgeEngine container that represents the demonstration microservice, and finally you'll exercise the demonstration microservice from the command line. In order to get full benefit from taking this track, you should know the basics of working with the edgeEngine microservice. And there is a previous video and Instruqt track we did that explains it, and we'll put the link below so you can view it if you need to review. I'm going to do the work of installing the WASM Microservice under edgeEngine and getting it up and running. So let's start the lesson. So the first thing we need to do is to get edgeEngine from GitHub and install it in the Instruqt interactive learning environment. So we'll run the curl command, and then we'll uncompress the tar file that was returned, and then we'll go into the working directory, and then we're going to start edgeEngine by using the no-up command and running it in the background, and this will allow edgeEngine to persist from lesson to lesson. Okay. Then we're going to clear the screen. Okay, so edgeEngine is installed. So the next step we need to do is to get the mimik edgeEngine CLI tool. So let's start this lesson, and we're going to install the CLI tool as a node package. So we're going to go out to npm and get the package and install it. And so to do that, we use npm install. And then to check that the CLI tool has been properly installed, we're going to execute it using the account subcommand just to get some runtime information. And that's done with getMe, the getMe option. And we'll send that into JQ to get some pretty JSON. And JQ comes pre-installed in this track. So there you can see that. Now the thing to notice is there's no account ID. So edgeEngine is running on this local environment, but it's not connected to the Mimik Cloud yet, and that's going to be what we're going to start doing next. But before we do that, we need to get the WebAssembly build and compile tools. Okay, so we'll start. We're going to use apt update to update the Ubuntu environment, because this Instruqt interactive learning experience is running under Ubuntu 20.04. And then we're going to install Python and pip version 3, because the compilation tools require it. Okay, now we're going to get the WebAssembly build tools. And then we're going to go into the directory where the build tools have been installed. And we're going to create some environmental variables that will hold information we need to move forward. One piece of information we need is the WASI version, and we're going to put that into an environmental variable called WASI_version, and then we're going to persist that into bashrc so that information is available from lesson to lesson. And that's something that's particular to the way Instruqt works. Now, it needs to record all environmental variables created in a session in bashrc to have it persist. And we'll do the same thing with an environmental called WASI version full. Okay, now we're going to go get the WASI SDK code from GitHub. WASI stands for WebAssembly System Interface. So we're just setting up the whole WebAssembly binary development environment here. Okay, so we've done that, and now we're going to extract that code from the tar file that was downloaded using curl. And then we're going to take that information and put it into an environmental variable called WASM SDK path __. And that information is going to be sent to a shell script called WASM SDK.env for later use. Okay, so next we need to install the CMake library and get the WASM example code. Okay, start that. Okay, so we're going to install the CMake library using Snap, which is a package management utility that's available under Ubuntu. Okay, great. Now we're going to go to the home directory, and then we're going to go get the WebAssembly demonstration code from the GitHub Edge Microservice repository. Okay, let's go into the working directory that has the source code, and we're going to run npm install to install the library dependencies. And now we're going to get those environmental variables we saved previously in WASM SDK_env.sh, and we're going to run the source command to load those into this process memory. Okay, and then we're going to run the command build.sh and pipe that information to a page packageinfo.txt. And this build script comes as part of the mimik demonstration application code. Okay, then for step 8, what we're going to do is inspect packageinfo.txt. Okay, you can look and see there's a lot of information, but the information we're interested in is this last file, and that is where the tar file, which is the microservice image artifact, where that's located, and that's in deploy wasm tar. Okay, great. So now let's do some work here. Let's clean up the package.info file and get the last line of code. And we're going to take that last line of code and we're going to put it into a build path. We're going to extract the build path. Okay, now we're going to echo the build path. Okay, and this is where the microservice image resides. Okay. And now what we're going to do is we're going to take the build path and send it to /rc so that information persists from lesson to lesson. And then we're also going to create another environmental variable called ms_path that holds the path to the microservice. And we're going to echo it to make sure that it's stuck. And you can see this is the complete path to the microservice image. And now we're going to send that environmental variable also into /rc for later use. Okay, great. Now we need to go and create a mimik account. In order to create a mimik account, we're going to use the mimik web console, the developer console. Now, I'm going to show you how to do this, but I already have an account created, and I also have a project created, which you'll see in upcoming steps. But it's useful to see this here, so you learn how to get to the developer console, and you get that step 1. So we're going to go to here, and this will bring up the developer console, and you can see it already knows me, and it has my email address and password. Okay, and so let's move on to the next step. We'll start. And this content explains how to create a project and how to create an account and how to create a project, all that stuff. And I've already done that. So I'm not going to go over it. You can read it in line in the documentation when you decide to take this lesson. But the next thing we're going to do is create a developer ID token. And to do that, I'm going to start the lesson. And in here, this is directing me to go back to the Mimik developer console, which I will. So let me log in. I already have an account. And I'm going to go to Edge Projects. And as you can see, I already have a project. It's called Simple Project, so I'm going to log into that. And then you can see here there's a button called Get ID Token. That is the developer ID token. So let's go back to here. And this copy explains everything I just described. And let's grab this environmental variable here. I'll call developer ID token. And I'm going to go back to the Mimik web console. Get the ID token. I click the Get ID token. It says ID token. Click the copy icon. And then I'm going to paste it in here. Okay, hit enter. Okay, and now I've assigned the developer ID token to an environmental variable, developer underscore ID underscore token. And I'm going to save that to bash RC for use in later lessons. Okay, now I need to create an access token. Okay, so I'm going to echo the developer token in step 1, just to make sure it's still there. Okay, and there it is. And now I'm going to get an access token. And the access token is the identifier of this session in the Mimik cloud. Okay, and then when it comes up, I'm going to actually have to associate the token, but first I have to create the access token. So I'm going to use Mimik Edge CLI account get edge access token -t, and I pass in a developer ID token. That's this format of the command. And I'm just going to send the output to access token.json. Okay. And now let's go get the access token, and I'm going to do that by using the cat command to get the file and then pipe it into JSON and pull out the property.access token and assign it to the environmental variable access token. Okay. And then I'm going to do some housekeeping by getting unwanted quotation marks out of that value. And now I'm going to echo the access token. Okay, so there's the access token. So we created developer ID token, used it to create an access token. Now what I'm going to do is I'm going to export the access token to bash RC for later use. And the next step is to associate the access token to the account. That's a third step we need to do. All right, so let me do the access token. Echo it just to make sure it's still there. Good. And so now we're going to associate the access token. And to do that, I'm going to use Mimik Edge CLI, the CLI tool, use the account subcommand and the associate subcommand, passing the access token using the option /t. And I'm going to pipe the whole thing into JQ to have it show up as pretty JSON, the result. And then you can see that we've successfully associated the the access token, and now we have the account ID. We know which account this access token belongs to. Okay, so the next step is to deploy the microservice image that we're going to use. So let's deploy the image. Okay, so we're going to go into the working directory of the source code, demonstration source code. And we're going to go into the build command. And the demonstration source code working directory is WASM example CPP -microservice. And we're going to go into the build directory. Okay. And then what we're going to do is we're going to deploy the image using the CLI tool, using the image subcommand and deploy subcommand, passing in the location of the tar file where the microservice is. And also we're going to pass the access token using the -- token underscore. option. And we can see that. And let's take a look at a pretty version. Okay, so now we have a pretty version. So the image has been deployed. The image has been deployed, and that's a WebAssembly binary. Okay, good. You can see the confirmation there. And now we're going to create another environmental variable called MSImageName. Okay, we're going to echo the image name. Okay, and that's the image. WASM example v1. Okay, and now we're going to send that to bash RC. Okay, good. So the next step is, now that we have the image, is to deploy the container, to create a container based on that image. And you've probably seen this pattern before under Kubernetes. It's image container. edgeEngine has a similar pattern in that it creates a image that gets deployed as a running instance in memory as a container. And that makes it subject to management by the edgeEngine runtime. So let's start it. Okay, so let's go into the working directory where the demonstration code is. Okay, great. Now we need to create a start.json file. And a start.json file tells the container not how to start up, but how to configure itself upon startup. So we're going to cat start.json. And this is taking information from the MSImageName environmental variable, and we're just saying here's the path that will append to the URL of the microservice. Very mimic specific. Okay, and let's take a look at cat to make sure the environmental variable is stuck. There you go. And that's good. So we have things going on, and now we're going to do another CLI command. In this case, container deploy, and it's on the payload. It's looking for the payload information that's in the start.json file we just created, and it's also looking for the access token. And we're going to pipe the contents into container deploy.json. Okay, good. And then we're going to cat container deploy.json. Okay, and you can see there's everything we need to know about the microservice. It's running. It's the startup. There is a microservice in there, and we can use it. Okay, so now we're going to extract the value of the base API path. And this will tell us how to get to the microservice once we start creating URLs to get up and running. Okay, and then we're going to echo the base API path. Okay, great. And then we're going to save the base API path to bash RC so we can use it in the following lesson. Okay, great. Next step is exercising the edgeEngine microservice. Okay, so let's echo the base API path. Okay, and this is the path to the microservice that will be appended into the localhost call, and that will be routed by the edgeEngine runtime to the appropriate microservice running in the environment. Okay. So we're going to run a curl. Let's take a look at what we have. So we're going to run curl, and we're going to say, okay, by the way, run on localhost on this machine, because the edgeEngine runtime is running on the localhost, and then go to the base path and go to the time endpoint. And when we take a look in a minute about how the microservice code actually works, you can see how this endpoint realizes itself. Okay, so we do that, and you can see the microservice reporting the current time. And that's exactly what it's supposed to do. And if you wanted to take the time when you do this lesson to investigate the source code, we provided a source code editor in here. And if you go to main CPP, you can see that this is where we report the time. Okay, so there you have it. We've created a edgeEngine microservice as a WebAssembly module. We compiled it up and we've deployed it, and we're ready to go.